this is a connected with the effect. It's coming. This is the DVD that was prepared by an engineer. This is a DVD prepared by an engineer at the entrance. Since this is an Italian peninsula, they put an aria by Giuseppe Verdi, Va Pensiero, the thought that goes. And then in honors of our Jewish friends that are here, they selected the chant of the Hebrew, very famous from Giuseppe Verdi. That's it.
My name is Gene West. I am an engineer of High Fuels Inc. I have conducted the measurements confirming Professor Santilli's ISO redshift and ISO blue shift.
My name is Gino Amato. I am the computer technician of High Fuels Inc. I have assisted Gene West with the compilation of all spectrograms.
I am Michael Maravich, a building specialist of High Fuels Inc. I have constructed the ISO shift testing station.
I am Chris Lynch, a mechanical engineer of High Fuels Inc. I have assisted in the high pressure engineering specifications of the ISO shift testing station.
My name is Michael Rodriguez. I am the electrical engineer of High Fuels Inc. I have constructed the various electrical components of the ISO shift testing station.
In a paper published in 1983 by the Italian Physical Society, Professor Santilli achieved the enlargement of the Lorentz-Poincaré symmetry, today called the Lorentz-Poincaré-Santilli isosymmetry, providing the universal invariance of the most general possible interior dynamical systems.
Subsequently, Professor Santilli discovered that his new invariance predicts a frequency shift of light propagating within transparent physical media without any relative motion between the source, the medium, and the detector. The prediction of the new shift was first published by Professor Santilli in 2 volumes of 1991. The first on the new mathematics necessary for the construction of the new symmetry, which he called isomathematics, and the second volume on the enlargement of Newton, Galileo, and Einstein theories for interior dynamical conditions. In view of their derivation via the new isomathematics, he called the new shifts ISO redshift when there is a decrease of the frequency and ISO blue shift when there is an increase of the frequency. In the same volumes of 1991, Professor Santilli proposed the conduction of a number of experiments to verify or deny these predictions, such as the measurement of the wavelength of light from a faraway star before and after passing through a planetary atmosphere, the measurement of a number of wavelengths of the sun in the transition from zenith to horizon, and other experiments. Following 2 decades of lack of interest by the physics community to conduct the proposed experiments, in 2010, Professor Santilli conducted the test on his own by achieving a confirmation of all predictions made in 1991. These results were published in Open Astronomy Journal In this DVD, we shall present the initiation of systematic independent conformations of Santilli iso redshift and iso blue shift.
Let us begin with a description of the iso shift testing station. As you can see, it is composed of 3 parts. The first cabin here on my left hand side housing various lasers. A second cabin at the end housing the wavelength analyzers. And 2 pipes connecting the 2 cabins. One of special steel for high pressure and the other in PVC for various collateral data. As you can see, the interior of the laser cabinet contains the lasers on this table and facing the terminals of the pipes. An air conditioning unit and related duct to keep the lasers at constant temperature of about 70 degrees and other equipment. The high pressure steel pipe initiates with a Lexan window you can see here. The high pressure steel pipe then continues for a length of about 60 feet or about 20 meters to the other shed. As you can see, the end cabin contains a second Lexan window at the end of the pressure steel pipe, plus various means of measuring wavelength, such as this wavelength analyzer. We also have an air conditioning unit and related ductwork to keep the analyzer at a constant temperature of 70 degrees Fahrenheit. We also have various recording means that are processed by our engineer, Gino Amato. A main feature of the iso shift testing station is that according to Professor Santilli's original conception, there is no relative motion between the laser, the analyzer, and its interconnected medium inside the pipe constituted by a gas at pressure. Correct measurements of the iso redshift require the laser and the analyzer at constant low temperature of about 70 degrees Fahrenheit, while the pressure pipe also must be at a low temperature of a maximum of 70 degrees. According to Professor Santilli's principles, the gas contained in the pressure pipe has to be at a sufficiently low temperature to assume all of its atoms in the ground state. Under these conditions, the energy needed for the interaction is provided by light, resulting in the increase of the wavelength with the consequential redshift. Under these conditions, the energy needed for the interaction is provided by light, resulting in the decrease of frequency with consequential iso redshift. Correct measurements of the iso blue shift also require that the laser and the analyzer be at constant low temperature of about 7 degrees Fahrenheit, but the pressure pipe has to be at a sufficient high temperature of at least 130 degrees Fahrenheit. According to Professor Santilli's principle, the iso blue shift requires that the gas in the pipe be at a sufficiently high temperature so that its atoms are in excited state. Under these conditions, the energy for the interaction is predominantly released by the excited atoms, resulting in an increase of frequency of light with consequential iso blue shift. Acceptable measurements for an iso redshift are done at night or early in the morning due to generally high temperatures here in Florida. We first compress in the steel pipe a gas up to 2000 psi are about 166 bars via this compressor. And then verify that the laser and the analyzer and the pipe are at a maximum of 70 degrees. When we then measure and record the wavelength of the laser light coming out of the terminal Lexan window with the pipe at 2000 psi. We then remove the gas in the pipe as fast as permitted by safety and pull a vacuum on it with this pump. After verifying that the laser and analyzer have remained with the original temperature, we measure the wavelength of the laser light through the pipe at a vacuum. Comparison of the two measurements clearly show a measurable, systematic, and reproducible shift toward the red of the wavelength at pressure compared to the wavelength under vacuum. Since the red shift occurs without any relative motion between the laser, the analyzer, and the gas inside the pipe, the measurements confirm Santilli ISO redshift. Note that we do first the measurements at pressure and then those under vacuum in order to minimize the lapse of time between the two measurements. In fact, bringing the pipe to pressure requires such lapse of time to cause significant climatic changes with consequential loss of accuracy. The measurements of ISO blue shift are done during the day when the pipe is exposed to strong Florida sun. We then follow the same procedure as that of the ISO redshift, namely, we first measure the wavelength of the laser when the pipe is at pressure and at about 130 degrees Fahrenheit. We then empty the pipe as rapidly as permitted by safety and pull a vacuum. We measure again the wavelength of the laser propagating under vacuum and compare the two wavelengths. Under the indicated conditions, we have seen a systematic shift to the left of the wavelength of the laser at pressure and at temperature compared to that under vacuum. Therefore, these measurements confirm Santilli ISO blue shift. We have also done a third type of measurements as follows. We first measured the wavelength of the laser with the pipe at pressure and at low temperature by measuring an ISO redshift. We then keep the pipe at pressure and wait until the sun is at the zenith to achieve maximal temperature of the pipe while continuing to monitor the wavelength of the laser. During these measurements, we have seen the wavelength change from ISO redshift to the ISO blue shift, thus necessarily passing through a no shift value. These observations confirm Santilli's no ISO shift, in which energy loss by light is balanced by the energy released by the medium, resulting in no measurable shift. The measurements of the no ISO shift are important to prevent possible erroneous repetitions of the measurements with claims of no shift that would be quickly disproved by experts in the field. Let us now review Professor Santilli's original measurements of ISO redshift. Professor Santilli's main objective was to establish that the redness of sunlight at sunset is due to a violation of Doppler's law within our atmosphere. Since the redshift occurs
in the absence of relative motion between the sun and our Earth. He argued that the sky is blue when the sun is at the zenith because red light is quickly absorbed by our atmosphere, thus leaving blue the only penetrating light in our atmosphere, as it is the case also in water. Consequently, Professor Santilli argued that if red light does not reach us for the short vertical trajectory, it is impossible for red light to reach us after traveling in air for about 10,000 kilometers. The sole possible interpretation of reality was therefore that blue light was redshifted during its long travel in air without any relative motion, and called this effect iso-redshift for certain technical reasons. Professor Santilli dismissed the old conjecture that redness at sunset is due to the predominance of the scattering of red light over other frequencies due to the impossibility for red light to reach us at the horizon. In any case, the scattering conjecture is not applicable to the case considered by Professor Santilli, which is the redness of direct sunlight at sunset, since scattering does not exist along a straight line. In spring of 2010, Professor Santilli built the ISO-shift testing station and initiated systematic measurements of iso-redshift with the technical assistance of known U.S. laser experts Kevin Kay and Brian Rogers, as well as other technicians. Note that the main objective was to prove the anomalous redshift of blue light in our atmosphere at sunset. Therefore, Professor Santilli was forced to use a blue laser light and air as gas. For this purpose, he purchased a 400 microwatts blue laser as shown in the picture and passed through the laser light at the exit and then into the wavelength analyzer. As indicated earlier, he measured the wavelength of blue laser light when the pipe was empty, then at pressure, and compared the results. The picture presents the first experimental evidence of Santilli iso-redshift obtained on June 27, 2010. This evidence was then confirmed by several additional measurements. This picture shows the increase of the iso-redshift with the increase of pressure of air in the pipe. Since the increase of pressure under the same length is equivalent to the increase of length under the same pressure, the latter measurements establish that the iso-redshift increases with the increase of travel in air as it is visible to the naked eye. It should be indicated that Professor Santilli only wanted to establish the existence of the iso-redshift and not its value for a given pressure of air in the pipe due to the clear preliminary character of the station. Following systematic confirmation on the existence of the iso-redshift, Professor Santilli released a paper for publication in the Open Astronomy Journal. This paper clearly predicts the iso-blue shift, although Professor Santilli did not try to measure it because calculations indicated the need for high temperatures requiring special equipment. The indicated paper also predicted the no iso shift as a necessary intermediate step between iso-redshift and the iso-blue shift. We initiated our independent verification of Santilli ISO shifts in early June 2011 and continued measurements through mid-August 2011. We improved the accuracy of the original measurements by Professor Santilli by eliminating the mirrors and placing the analyzer directly in front of the exit window. We then assured that the blue laser and the spectrometer were kept at constant temperature of about 70 degrees Fahrenheit via ducts from the air-conditioned units as shown in the pictures. Next, we discovered, mainly by accident, since it was predicted but not expected by Professor Santilli for the available setup, the transition of the shift with the increase of the temperature from the right to the left of the base wavelength in vacuum. This is illustrated in the picture of June 15th, 2011, which is the first evidence of Santilli ISO blue shift to our knowledge. Consequently, we set rigid standards for the measurements of the ISO redshift, requiring the pipe at a maximum of 70 degrees Fahrenheit and the ISO blue shift requiring the pipe at a minimum of 130 degrees. In both cases, with the laser and analyzer at 70 degrees Fahrenheit. The following three spectrograms show representative cases of ISO redshift obtained under the above conditions, showing values of the shift of the order of about 0.05 nanometers, although with decreasing value due to temperature increases. The subsequent spectrograms show corresponding ISO blue shift, also for different values due to variations in the pipe temperature. These additional spectrograms are currently under investigation due to the double peak, one redshifted and one blue shifted. We should finally note that our measurements leave open the possible correct value of the ISO redshift measured by Professor Santilli. In fact, Professor Santilli's first measurements showed an ISO redshift of about 0.5 nanometer, while our measurements show an ISO redshift of only 0.05 nanometer. However, Professor Santilli's first measurements were done in the winter with the pipe at low temperature, while our measurements have been done during the Florida summer with 70 degrees Fahrenheit being the lowest possible temperature of the pipe. To resolve these different values, we plan to complete the pressure pipe with suitable cooling means to bring its temperature down to freezing temperature and repeat the measurements at that temperature. Even though we are not in a position to provide exact numerical values of the ISO redshift under given conditions, we can safely confirm that Santilli's ISO redshift clearly increases with the decrease of the temperature of the pipe under the same trajectory of the laser and the same air pressure. Needless to say, we encourage all possible additional independent verifications by interested scientists, since there is so much still to be understood and measured.
Upon completion of the preceding measurements of the ISO redshift and the ISO blue shift, we conducted a second group of experiments aimed at the experimental confirmation that redness of the sun at sunset is due to Santilli's ISO redshift. For this purpose, we set up equipment here shown consisting of a conventional telescope converging sunlight into the analyzer, capable of detecting a band of wavelengths from blue to green. We then first measure and record direct sunlight when the sun is at the zenith, as done here. We then measure and record direct sunlight when the sun is approaching the horizon at sunset. Unfortunately, we could not measure direct sunlight when the sun is actually at the horizon because our telescope provides spectrograms excessively dim for accurate measurements. In fact, when the sun is at the horizon, there is need for large parabolic mirrors to converge sunlight into the analyzer. These measurements are contemplated for conduction at some future time.
Today is Wednesday, August 3rd, 2011, and we are at beautiful Sunset Beach in Tarpon Springs, Florida. This is the location where we capture the measurements of the direct sunlight at sunset.
As stated before, the light below around 20 degrees above the horizon is too dim and too small for us to measure accurately. This telescope and analyzer are the equipment we use, also the computer, to capture the measurements at sunset.
Is it an emergency? With your son? I'm not yelling, I'm talking. Is it an emergency?
In this and the following spectrograms, we show in the top sunlight from blue to green when the sun is at the zenith, and in the bottom, the same light when the sun is about 30 to 10 degrees from the horizon. These spectrograms show a clear, systematic, and repeatable ISO redshift on the order of 1 to 2 nanometers, even though the sun shows no visible redshift at all. It is then evident to expect a progressive increase of the ISO shift with the decrease of the angle of the elevation. Despite their preliminary character, our measurements do confirm Professor Santilli's ISO redshift origin of the redness of the sun at sunset. In any case, we should keep in mind that such origin is the only possible one due to the impossibility of using any form of scattering for the case of direct sunlight. Needless to say, we encourage all possible additional independent verifications by interested scientists, since there is so much still to be understood and measured.
We conclude our presentation by reporting a third group of measurements we have conducted with the same blue laser light and the same wavelength analyzer used for the preceding test, but in a different experimental setup. The objective has been the measurement of the wavelength of the blue laser light when reflected by a polished aluminum surface at increasing temperature. As one can see, this is the laser, this is the reflective surface, this is the analyzer, and this is the torch applied to the back of the aluminum plate. Systematic measurements conducted at various times have established the absence of any shift in the reflection of light under the above conditions in the transition from ambient temperature of the order of 80 degrees Fahrenheit to about 300 degrees Fahrenheit as shown in the spectrograms. This result is presented in the hope that theoretical physicists may study its possible implications for the scattering of light, since latter phenomenon is still significantly unknown.
I'm sorry, I'm tired. the technician asked me to convey special thanks to Professor Dehan, because it was very helpful to them, and by phone and by email. Professor Dehan has not seen personally, so actually I think it's the first time he sees these results. So, but I want to thank, because it was very helpful by phone and email suggestions and so on. Gentlemen, any ladies, any question, please? I try to answer to my best. There is no question that this experiment confirms incontrovertible deviations from special relativity within physical media. Those deviations implies changes in basic features of light. It is impossible even to think that this is remotely realizable with the simple equipment unless there is a change in the structure of space-time. The air alters the very geometry of space-time as a necessary condition to alter any feature of light. We can discuss the type of appropriate modification of Minkowski, anything you want, yes, but not the existence of a very structural geometric alteration. And this is, it is also my opinion that this, even though you have not heard Professor Nims, this is a direct verification, because you change the physical conditions. I can tell you immediately you can get speed bigger than the speed of light.
A question by Professor Verrolt.
Please.
My question is that I do not, first of all, I do not have any doubt of those experimenters on those results. I see that there's a real ISO redshift. But about the color of sunset, which is very red, what is your opinion about the fact that sunlight is polychromatic, and then through diffusion of light through the atmosphere, then much of blue light is scattered, and only the red part of the polychromatic source stays, and which makes this very deep red color. Because I doubt that the ISO redshift, which amounts to
we know. This is the orthodox view of the 20th century, and that there is a view that we adopted. But then, after doing calculations, I have to. That's what Gene West said. You see, what you stated is absolutely true. Namely, if you look at the theory of scattering, what you state is true. Is a scattering law, so it's unquestionable. But you see, this has been the view of the entire the 20th century. We cannot adopt, we could be wrong, I beg you, but I will tell you my view. Our view is the following. Before applying this law of scattering, there is the necessity of applying another law of relativistic quantum mechanics, which is the law of absorption. It is impossible for the red light to propagate in the horizon through the 10 or 15,000 kilometers. Has been proven to be absolutely impossible. And this is what he said. He said, look at in other words, if the sky were red, your argument will be absolutely true, because it means it means since the sky is red, that when the sun is at its zenith, when we got the horizon, the redness increases. But the sky is blue because the red light is gone already in this very short trajectory. So how can it possibly survive? There is no chance that we, with calculations, not with philosophy or epistemology, no, with real calculations, we could never get even a minute fraction of the red light reaching us at the horizon. That has been our experience. So careful that what you state is correct. Again, I have to say that what the 20th century view of the predominance of the scattering, yes, the scattering increases with the increase of the wavelength. This is obvious. First-year graduate students knows that. But we have to make sure that the red light is there to have a predominant scattering. And that's where this turned out to be a belief. Only belief, but not as an experimental truth. In any case, as experimental evidence at this time, which can only be dismissed via counter-experiment. There is experiment can only be dismissed by counter-experiment, not by theoretical conjecture or calculations of theory that are inapplicable in a physical medium to begin with. So the physical reality at this moment, which we invite to verify, is that the redness has an origin of iso-red shift. It's the blue light that turns into red. This is a physical evidence, which has to be dismissed with counter-experiment. And not with so your argument does not dismiss the measurements. No way. No. Because you have a clear short. Now, if you look, unfortunately they are not here, but you see an entire band of frequency from the green to blue, and you can see all of them. You put the cursor in all of them. You go from the band on the zenith, the band at the 30 degree. Incidentally, it was at 30 degree, not even very low. Because it was too low, the intensity at the horizon was too low. So if you put this cursor, all frequency, you can see this shifted image of about 1 nanometer, 0.1 nanometer. You can see systematically for all frequency. So as far as we can see, it's incontrovertible experimental evidence, unless dismissed by counter-experiment. Strongly object against any theoretical conception, epistemological or other, please. Because what is at stake here is a lot.
Professor Uderiste.
Please.
I appreciate very much this kind of experiments that confirm a part of the theory of Professor Santilli. But I have a suggestion. Would you be so kind to advise them to realize instead single time spectrogram, temporal spectrogram? Because this kind of zigzag is not concludent. In my opinion, it's better to have like a surface, b-dimensional surface, means to evaluate not only in time, to evaluate also in another parameter. For example, to explain what I want, in what I have in my mind, a signal like y of t equal sine of omega 1 t, sine omega 2 t, and omega 1 is far from omega 2, then it is totally suitable to replace in sine of t1, sine of t2. Yes. And then you realize, like in electronics, a very interesting...
Professor Udris, I'm sorry, we are short of time because we have to go. I see this is a beautiful proposal. Magnificent proposal. I definitely recommend you to do it with an experiment. I can locate funds for you. Let's do experiments and stop doing the talking. This is the very excellent idea, Professor Udris. Yes, but there's no connection with this. Here is dedicated to frequency. The behavior of frequency of electromagnetic waves propagating in a physical medium. But your setting is very interesting, but it's distinct from this one. A few other questions, please, because we have another lecture and then we have to go to the... Please.
We are very...
Go ahead.
The last question, because we are very late. We cannot, of course, head of state cannot wait to
Carla,
us.
what is the change of plan? Oh, my early when? No, it's impossible. No, because they cannot change at the last moment. Carla, they cannot change. No, Carla, we cannot change it. They should have told at least this morning. Please go and tell them that this is not possible. We have to close the session. It cannot be changed at the last moment, not this way. It's an interruption of the... Professor Corda, you are in charge of the schedule, so shall we shift the lecture at the beginning?
The program was till 12:30. Okay, we finish at 12:30 in point. Very quick.
Yeah, Ruggiero, just a quick question. Obviously, your ISO redshift is the velocity is modified by the refractive index. Now, in your experiment in the tube, which was 20 meters, you were doing an air pressurizer I believe, about 160 bar atmosphere. So if you assume the density is equated to the refractive index, that equates to roughly a kilometer of air. So obviously your data that, blue light is shifted to red is, on the order of magnitude is correct in terms of your tube. So what I want to know is the refractive index indeed directly proportional to the density of the media?
Professor Ying, this is another very deep question, very, very deep question that deserves some additional experiment. And it is linked to the Professor Nim's experiment. All this, if we enter into details, you'll see deeply, Professor Kolminsky and so on. Yes, of course, it's directly, N4 in our geometry is a geometrization of the density, but no way. What we, for instance, what was not mentioned officially, now we are beyond the official lecture, what I want to indicate personal opinion, Professor Nims, Professor Kolminsky, for you in particular, we suspect also a change in the speed of light. In other words, now, whether and when this can be measured is a different issue. In particular, we expect an increase of the speed of light associated with the ISO blue shift and a further decrease associated with the ISO red shift. We suspect. The geometry indicates that, but it does not mean that it exists until it is actually measured. So for a number of various reasons, as a matter of fact, if there is a prediction that when the temperature of the plasma reaches a certain critical temperature, the speed of light in vacuum is surpassed. It is a theoretical belief at this moment because it has to be verified. So the dependence of the index of refraction is extremely complicated. Besides the pressure and the temperature, then when you go at the particle level, there's a non-local effect. So it depends on the wave function and the derivative of the wave function and the frequency itself, etc., etc. The different frequencies, as you know, have different. But it will be nice. It will take a century to understand experimentally the actual dependence of the index of refraction.
Okay, we have to stop here the discussion. We have to start the last lecture by Professor Santilli of this morning because at 12:30 we have to go to the reception with the head of the state of San Marino.
For the technicians who will be job. Any question, any additional question, please? We are now a couple of few minutes. Please, any question is welcome. Criticism in particular. Or suggestion for additional experiments. For instance, is there any way we can measure the speed of light? Let me put it a different way. I have an unconscious repulsion to accept that the frequency can be changed and the speed remains the same. It's beyond my instinct. So is there any way we can measure, with a longer pipe, we can measure the speed of light? Keep in mind that I accept is an important point. Let me make it for whatever it's worth. Again, let me communicate my feelings for whatever they're worth. Again, I am devoted, the special relativity is sacred for me, as stated by Einstein, namely in empty space. The moment you are in a physical medium, I'm sorry, I cannot even define special relativity. I cannot introduce inertial reference frame in our air because of the resistance of our how can you introduce a reference frame? And you cannot reduce those effects to elementary particle and introduce a tiny little reference frame just to preserve everything at a particle level. Those are manipulation, ladies and gentlemen. They're a very deep issue. So the question is that the speed of light is a variation, extremely complicated variation, that it points incontrovertibly toward speed bigger than the speed of light in a fully causal way. That is why I'm so supportive of Professor Nims and Professor Kolminsky and everybody else who has done those seminal experiments. And, please.
I went to a workshop in experimental gravity that was in southern India, And the head of the Tata Institute had his own variations of standard, light speed theory. He's the head of Tata. And he was there, and he was talking about when we go to the Michelson-Morley experiment, that, the idea would be that you have one light going at one speed and going the other way. They just said the speeds would be identical. And he said under certain circumstances that was not necessarily true, and it had direct implications in terms of what we can see in VR and some things in cosmology. In other words, he said that there was a systematic deformation of the basic type of experimental type of protocol in evaluating CMVR, because that some things about light speed that were, the speed of light and some other type of measurements have been systematically been, what you might call, distorted. Now, what I will do is that I know the head of Tata, and I was a speaker at that in early in 2009. I am going to make available to you when I go back to where I came from. I will send you the link, and I think it will fit directly in. As a matter of fact, you might enjoy what you might call trying to explain what he was observing empirically in terms of its effect. It also affected redshift issues too.
Yes, of course.
Yeah, it was very, very fundamental. Yes. And what I will do is that I will when I go back to my apartment, I will find that experiment. It was, proceeds in experimental gravity, early 1989, run by Tata, and I was one of the speakers. Get it to you. And I think this man would love to get an explanation, maybe in terms of yes.
You have new mathematics, new physics, you have new symmetries and everything. There is a very.
But what he said though is that there was a systematic altering of the reliability of some things in terms of CMVR type of information, which meant in effect, which is what was being read of the sort of thing was not necessarily accurate.
Under the condition. Again.
I'm really sorry to keep insisting, but we must go because they keep asking us to
leave. Under the condition that, let me finish this comment you finish. Under the condition that the variation are in anything deviating from empty space, because I consider the special relativity sacred in empty space, then all this applies in an invariant way. Not only we can predict changes. That's why we hope to predict repetition of Professor Nim's experiment, of Professor Nim's.
Well, I think the head of Tata would love an explanation for what he was trying to explain in Jericho when he was live.
Oh!
If you could give it, he would give you a thumbs up on that. He really would live.
Those measurements.
It might be directly linked with what you brought up today.
Yes, those measurements they confirm directly with that.
But he brought it up and he said, I can't produce a sort of things in real time.